Hello, I'm Jonathan from Shooting Stuff. Today, I'm going to tell you a little bit about bullet construction, what I've learned, where we've come from, what we have today, and where we're going to. So most rifle hunting bullets are made with a lead core surrounded by a copper alloy jacket. Lead is the traditional preferred material because it's dense and because it's cheap. So bullets can be made cheaply using lead, but lead itself interacting with the barrel is too soft and would melt, especially as we push our bullets to higher and higher velocities. In the good old days when muskets were invented and muzzle velocities were around 1,000 feet per second, as is the case for many handgun calibers today, a normal lubricated or even unlubricated lead bullet would be sufficient. But as velocities have increased beyond 2,000 feet a second, 3,000 feet per second, and even beyond 4,000 feet per second now, lead would simply melt in the barrel and create mechanical buildup, which compromises accuracy as those high velocities are achieved, and the friction between the very fast bullet and the barrel results in the lead melting onto the barrel. So the solution was to introduce a copper jacket on the bullet. And initially we were focused on a full metal jacket where the lead core was inserted from the back of the bullet, and we have a solid front of copper. It was the first way that the bullet was constructed, and it served well for many years. As a way of enhancing the performance of those bullets, the production process was turned around and a bit of the lead core was left exposed. The soft lead aided the initial expansion when the bullet hit the target, and the hunting bullet was formed. We've gone through many shapes depending on the purpose of the hunting bullet. Many of the initial designs were simply round, like this one. And as the velocities increased and the desire to hunt at longer ranges increased, so the necessity evolved for bullets to become more aerodynamically efficient. So as an example of an early hunting bullet with an exposed lead tip, this one has got a flat base, very similar to this. And the flat base is often an example of a short range, typically out to 200, 300, 400 meters. But as the desire to go to longer ranges evolved, people started putting a boat tail and this angle at the base of the bullet to reduce the drag. The high velocity air moving around the bullet stays attached to a smaller diameter because of the boat tail, and the base area that sucks the bullet back and causes the drag is reduced with the boat tail. Longer, more gentle boat tails like these are more efficient, allowing these more streamlined, quite sexy looking bullets to be much more aerodynamically efficient out to longer ranges. Whereas the muskets and flintlock rifles of the old days were really affected up to tens, maybe 100 yards or 100 meters or so, modern bullets are often utilized out to kilometers. PRS type competition, shooting steel gongs, frequently engage targets out to 800, 900 meters, sometimes 1200 meters. The mystical mile at 1,600 meters is always a fantastic challenge for a variety of calibers up to the likes of .308. And for those with the bigger calibers, 338 Lapua and so on, reaching out to 2 miles, and the king of 2 miles competitions, 3,200 meters or 3.2 kilometers, requires bigger calibers and very streamlined bullets. These streamlined bullets have a much more gentle ogive, often partially filled with lead, so the front of the bullet often does not have any lead in it. It's left open or is fitted with a lighter compound, whether it's a heat-resistant polymer or an aluminium tip, just to keep the center of gravity back in the bullet for better dynamic stability as the velocity drops down into transonic and subsonic velocities. So many of the long-range bullets, whether it's for long-range hunting or target shooting, start off at very high velocities, often in excess of 3,000 feet per second, close on 1,000 meters per second, and at extreme ranges, 3 kilometers or so, the velocities are going to often drop down to the transonic region at about 1,000 feet per second, so about 300 meters a second. A vast difference in velocity, and the drag characteristics and the aerodynamic stability of these bullets changes dramatically in that region. So bullet designers are trying to optimize the center of gravity, the shape of the bullet, so that accuracy is maintained even out there. But for many of the hunters, that sort of long-range use is almost irrelevant, because most animals are hunted inside of 300 meters, and aerodynamic efficiency is not required there. So the flat base bullets, whether it's a round nose or a Spitzer, are normally perfectly adequate for those sort of velocities. You want a bullet for hunting purposes that ensures that the entire bullet can penetrate deeply into the animal to cause damage in the vital organs, the heart, the lungs, the liver, and incapacitate and kill the animal efficiently. To do that, you need weight inside the animal to allow the bullet to penetrate deeply, and a lightly constructed bullet with a thin jacket, for example, that can easily break up, would not generally penetrate deeply. So a thicker bullet jacket is utilized on bullets designed for hunting bigger game. And the bigger the game, the thicker the jacket and the stronger the jacket needs to be. One of the problems that happened early days of the bullet design was that the jacket separated from the lead core, and you had a bunch of small pieces, none of them penetrating very deeply, and a bunch of technology went into figuring out ways to make the bullet stay together for longer inside the animal. And that led to bonded bullets, where the lead core is chemically bonded to the jacket. It led to mechanical attachment of those bullets from the interlock design that Hornady uses, the nozzler partition, which created two separate components of the lead core, one which couldn't push out the front. These are all different technologies that result in a bigger, stronger piece of the bullet being able to penetrate to the vital organs. There's a move away from lead around the world, which will result in bullets becoming more expensive, because lead is actually a very cheap and freely available heavy metal. The non-toxic bullets are developed in a variety of calibers for places like California, where lead is banned, and that is a new or different type of bullet construction following the traditional core and jacket format. The advantage of a core and jacket over a monolithic, which is another lead-free option, is the core and jacket being a softer core than the monolithics typically be are overall, results in a more forgiving bullet that shoots better in a wider variety of firearms, because the relatively soft bullet can obturate and seal against a wider variety of barrels than is the case with a monolithic, a much harder, tougher monolithic bullet. The monolithic bullets have gained popularity as a way of moving away from lead, but mainly because it's a uniform, tough material. They started off with really a hunting design, designed to expand, and the petals of the expansion generally remained attached, except at very high impact velocities, and a solid big chunk of the bullet stayed together to penetrate deeply into the animals. Being of a lighter overall material than a lead bullet is, the equivalent weight in the same caliber in a monolithic design is going to be a lot lighter. The monolithic bullets are generally made of copper or a copper alloy, and a wide variety of them have been developed and utilized to achieve different purposes. This particular one is a very easy to machine copper alloy designed for target shooting, while this is a more pure copper designed for better expansion as a hunting bullet. I hope you've enjoyed my take on bullet construction and some of what I've learned. I'm sure there's a lot that I haven't touched on, and I'm sure there's a lot that I'm still going to learn about all of these things. We're in an exciting age as computer technology allows bullet designers to develop bullets in a far, far more sophisticated way, and I'm excited to see what's coming in the next couple of years. Shooting Stuff will continue to try and make these available at our store in Centurion or online at shootingstuff.co.za. Remember, Shooting Stuff is here giving you more time to shoot.